about 4/4. A lot of it is review. A lot of it is stuff that we've already done, and then we just add some new stuff in. So although it looks like it's 17 slides and that's a lot, it's actually not that bad. Because, okay, part of it we already know. So we're now talking about the triangles literally being on our coordinate grid. So what happens if I put something on my coordinate grid? My angle is now on my XY axis, but my radius is not 1, okay? So with the radius of 1, all the unit circle angles apply, okay? But what happens when it's not? What we're creating is a right triangle. So if I were to put an angle like this one, right? So I gotta remember it's not my Apple Pencil. I have my y-axis, my x-axis, and if I draw myself an angle, right, there's my theta, and this point is no longer unit circle based, this is something different, then all I have to do is close in that triangle using the x-axis and the y-axis, and I can make my right triangle in which I can use SOHCAHTOA to find the trig functions. So you don't really need to know, like have this memorized, it can help, but if you just think about where your angle is, sine would be opposite over hypotenuse. The opposite in this case would be the y. The hypotenuse is going to be the radius. Cosine would be adjacent over hypotenuse, which in this case is going to be the x. That's your adjacent side. Hypotenuse is the radius. Tangent is opposite over adjacent, which would be y over x. And then obviously we flip them to get our reciprocal functions. Okay? So no matter where you move your angle to, notice that this angle is out here. We always close in the angle using the x-axis. So x is still my adjacent, y is still my opposite, r stands for radius, okay? And as you move it around, the x and y signs change. These would obviously both be negative, but the radius is always positive. So the hypotenuse of your triangle is always positive. The x and the y are going to change, which means my adjacent and my opposite are going to change sign, positive or negative. But the r is always positive, okay? We talked about this for a couple of sections. Now, obviously, knowing your angles around your unit circle in both degrees and radians is helpful. We did a lot with the positives, and then on the right is the negatives. Remember, as you go in the other direction, it changes that sign. Okay, we talked about our quadrant angles, what happens at these coordinate points. At 0, it's 1, 0. At pi over 2, it's 0, 1. At pi, it's negative 1, 0. And at 3 pi over 2, it's 0, negative 1. Because of those things, sine would be 0 at 0, 1 at 90, which is pi over 2, 0 at 180, negative 1, because it's the y, right? Cosine is the x, which changes from 1 to 0 to negative 1 to 0. And tangent is the y over the x. So at 0, it's 0. At the top, pi over 2, it's undefined. On the left, it's back to 0. And on the bottom, it's undefined. So we're going to use that again eventually in a little while. But if you just remember, tangent's undefined at the top and the bottom, and 0 on the right and the left, it will save you some time. Again, we don't want to be digging through notes to find those kinds of things. Those should be quizzes. All right, so what happens again if our endpoint is not on the unit circle? This is what it would look like. Determine the exact values of the 6 trig functions of each angle theta. So for A, my angle ends at 4, 3. 4 is my x value. 3 is my y value. My theta is in here, okay? So I have to complete this triangle. Do we know what the missing side of a 3, 4 triangle is? 5. That's one of your triples, okay? So knowing your triple is going to save you. 3, 4, 5, 6, 8, 10, 5, 12, 13. Those are the 3 most common ones. Then there's 7, 24, 25, 8, 15, 17, 9, 20, 25. Those are probably the most common, okay? And Corona perk, you get to write that down somewhere, okay? But obviously those are things that could cost you, what was it, $11,000, $16,000, because that's a triple, and that kid didn't know that triple. And if he had just known that triple on Who Wants to Be a Millionaire, he would have won a lot more money. All right, so now when you get the sides, obviously if it's not a triple, you have to use the Pythagorean theorem. But if it is a triple, then I find the third side, and then I find the sine. Opposite over hypotenuse, 3/5. The cosine, adjacent over hypotenuse, 4/5. Tangent, opposite over adjacent, 3/4. And this said 6, right? Yeah, 6. So I go cosecant, 5/3. Secant, 5/4. And cotangent, 4/3. Easy stuff, right? All right, now look at B. Now the angle is here, right? But we always close in the triangle using the x-axis. So even though the angle's there, we make our right triangle here. Theta still can be put here. It's called a reference angle, which we're going to get to in a minute. The x is actually -8 this time because we moved left. The y is +15, and we just went over this. What would be the hypotenuse? I just gave it to you. 17. 8, 15, 17 is a triple. Can you find it using the Pythagorean theorem? Absolutely. Do you want to memorize the square root of 289? Nope. So you might as well know those triples, okay? So now sine. Opposite over hypotenuse, 15/17. Cosine. Adjacent over over hypotenuse, -8 over 17. Tangent. 15 over -8. Doesn't matter if the negative's out front with the 15 or with the 8, as long as there's only one negative. I told you. Cosecant, flip the sign. Secant. -17 over 8. Cotangent. Oh, geez, sorry. -8 over 15. Again, remember the radius will always be positive, okay? Always, 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 always. So your x and your y can change from positive to negative depending on which quadrant that point is in, but your radius will always be positive. Questions so far? All right. Now, same exact thing, just not a picture. So it says this point is on the terminal side of the angle in standard position. Determine the exact values of the 6 trig functions of the angle. So -4, 7, if I want to draw it like accurate with my actual x and y axis, I can go left 4 and then up 7, close that in to get my triangle. Is there a triple with 4 and 7?
No.
No, so I got to use Pythagorean theorem. So -4 squared plus 7 squared, 16 plus 49, 65 equals my radius squared. Radius equals the square root of 65. Check to make sure it can't be simplified. This would be 5 and 13. Can't be simplified. So that is my radius. Square root 65. Then comes my sine, cosine, tangent, sine. Sine. Have you ever watched Dumber and Dumber? Like every time I hear that sound, that's all I think about. What's the most annoying sound in the world? Ah! It's pretty much that. All right. Sine is 7 over the new Dumb and Dumber stinks. I'm talking about the old Dumb and Dumber.
No,
Yeah.
The dog.
Yes.
And they pick up the...
Yes. Dumbest movie ever, but it's hilarious. Okay, so 7 goes over the square root of 65, and then it gets rationalized. 7 square root 65 over 65. Cosine, -4 over square root 65 gets rationalized. -4 root 65 over 65. Tangent, Opposite over adjacent, so 7 over -4. And again, that negative can be out front with the 7 or with the 4. It doesn't matter as long as it's only in one of those spots. You with me so far? Now we find the reciprocal functions, so we flip them. Remember that we flip before we rationalize, so save yourself the extra step. Go back to before you rationalize and flip back. So square root 65 over 7, negative square root 65 over 5, no, sorry, over 4, and -4/7. All right, B, I'm not going to work all the way through, okay? Just realize that the signs change. This time I'm moving to the right 3, down 4. Closing my triangle makes an axis, makes a triangle, makes it the angle with the x-axis. What would be the missing side?
5.
5, okay? You know where to go from there? We good? Yeah.
How would, you said it's always positive, right?
It's always the radius is always positive.
Okay.
Yeah. All right, we talked about this before also, but this is, remember, the acronym to help you remember which of the 6 trig functions, well, which of the original 3 trig functions are positive in each quadrant. The book gives you All Students Take Calculus. There's also All Snakes Tease Chickens. A smart trig class. All of them are the same acronym. They start in the top right and they work their way counterclockwise. So if you pair that with your unit circle and knowing where that angle falls, obviously that will help you with your positive negative signs. All right, so example 3 says name the quadrant in which theta lies if cotangent of theta is greater than 0 and sine of theta is less than 0. So talk about positive and negative relationships. If cotangent is greater than 0, what does that mean? Cotangent would be positive, right? So if all students take calculus, I already know cotangent has to be positive, which means tangent has to be positive, right? That rules out second quadrant and fourth quadrant. Then the second part of this says sine is less than 0. So we're saying sine is negative. So from what's left, which of the quadrants would have sine be negative? You want sine to be negative, right? In the first quadrant, they're all positive, so I rule that one out. The only one in which cotangent is positive and sine is negative is quadrant 3. Oops. All right, now put those last couple of things together. Given that the cotangent of theta is -4/3 and the sine of theta is greater than 0, find the following. First of all, remember I said as we start to blend these kinds of questions together, it's hard to determine if we're doing unit circle or if we're doing triangles. 4/3 is not on my unit circle, so I know immediately I have to draw myself a triangle. It doesn't matter what direction you draw it in as long as you apply the right sign. So don't worry so much about if does it have to point left or down or anything like that, as long as you remember to apply the right signs, positive, negative signs. So the cotangent is -4/3. That means my adjacent is 4 and my opposite is 3, but how do I know which of those is negative? I don't yet, right? That's why they give you this piece of information. So if the sine is greater than 0, it means the sine is positive. In order for the sine to be positive, the y has to be positive, right? Which means the negative is going on that 4. So they're always going to give you enough information for you to figure out which one of those gets the positive and negative sign.
But what if we drew it with the 4 on top and the 3 on the bottom?
It doesn't matter as long, the 4 has to be the horizontal and the 3 has to be the vertical. So don't worry too much about where you draw it because you'll go crazy. Just draw it out and then make sure that you write the right signs. Clearly, I should have really gone left and up. So if I was using the unit circle, it should have been like this, -4 and 3, but it doesn't have to be perfect.
Okay.
So then the missing side is again 5. It's +5 because the radius is always positive. And then my sign would be 3/5. The cosine, -4/5. The secant is the reciprocal of cosine, -5/4. And the secant is the reciprocal of sine, 5/3. Everybody good so far? All right, example 5 says the terminal side of theta lies on the given line in the specific quadrant. Find the values of the 6 trig functions of theta by finding a point on the line. So I now have a line, y equals 3x, okay? If I were to plot this line on my coordinate grid, how do I graph that? What's my y-intercept? 0, so I'd start at 0. And my slope?
Up 3.
Up 3, 1, 2, 3 over 1. So I'd have a line that looks like this. So what this is saying is the terminal side of theta lies on that line, which means I can literally drop that down coming from the point at the end. Unlock, hang on. I just unlocked it. There we go. I can drop this down and close it in, put theta here. Now my horizontal, and it's not very accurate, but my horizontal was 1 and my vertical was 3. Rise over run, 3 over 1, right? Now I've got my side length. Is 1, 3 part of a triple? No, so I got to do the Pythagorean theorem to find the missing side. 1 squared plus 3 squared. 1 plus 9, which is 10, and that missing side is the square root of 10. Now, find the 6 trig functions. So sine is 3 over root 10, which gets rationalized. Cosine, 1 over root 10, which gets rationalized.
Ms. Christopher?
Yeah.
How do I know to place the theta where it is?
The theta will always be in the little corner from the terminal side to the x-axis.
Okay.
It always goes nearest the x-axis. Tangent, 3 over 1, so 3. Then find your reciprocal functions. Cosecant, flip before we rationalize. Square root 10 over 3. Secant, flip before we rationalize, so just root 10. And cotangent, 1/3. My stomach is growling, so like this is catching my stomach growling, that noise. This is just a weird day. Questions? So notice that this slope is the same as my tangent, which should make sense, right? Slope is rise over run, which is y over x. So they're going to be the same, okay? Your slope should always be the same. So the fastest way to look at a question like this, it says evaluate the trig function of the quadrant angle if possible, is to make sure that you're familiar with your quadrant angles. So remember, we can know our whole unit circle, but we can also know some shortcuts, which would be knowing the quadrant angles, the coordinate points that go along there. This would be 1, 0, 0, 1, -1, 0, and 0, -1. And then obviously all your over 4s, over 3s, and over 6s help you too. But this one is a quadrant angle. So the sine of pi is here on the left. and the sine is the y, so this is 0. Cotangent, this should be over here. Cotangent of 3 pi over 2. Now I'm looking at 3 pi over 2. Tangent would be y over x, so cotangent is x over y. The x is 0, the y is -1. 0 divided by anything is 0. Now let's look at reference angles. So a reference angle of theta is the acute angle theta prime. This little apostrophe is read as prime in math, formed by the terminal side of theta and the horizontal axis. To find the reference angle, you're going to find the difference between the angle and the x-axis. So if you want to just picture the x and the y-axis for a moment, any angle that's in the first quadrant, and I'm trying to find the difference between that and the x-axis, would be itself. So the reference angles in the first quadrant are the same as the angles, meaning something like pi over 3, reference angle would be pi over 3, pi over 4, pi over 4, pi over 6, pi over 6. And then all the other non-special angles like pi over 7, reference angle is still pi over 7. In the second quadrant, my angle would be here, and I'd be trying to find the difference between the reference angle would be there. I'm trying to find the difference between the x-axis and that angle. So if I wanted to find the reference angle in the second quadrant, I would actually do pi minus theta. So let's just say I had 2 pi over 3, which is in that second quadrant. I would do pi minus 2 pi over 3. Pi is 3 pi over 3, and I'd end up with pi over 3. So that would be the reference angle for 2 pi over 3. Now, to know that all the reference angles of your special angles, which is anything over 3, anything over 4, and anything over 6, are pi over 3, pi over 4, and pi over 6, are going to be really, really helpful. The other angles, like if I had pi over 7 or 5 pi over 7, my reference angle is no longer pi over 7. It's actually 2 pi over 7. So it's just for these special angles that that's true. When you move into the third quadrant and you have an angle that's here, the reference angle is the distance again from the angle to the x-axis. But in the third quadrant, we do theta minus pi. So second quadrant, pi minus theta. Third quadrant, theta minus pi. And come all the way back around to that fourth quadrant, and an angle in the fourth quadrant, I'd want to find the difference between that and the x-axis. So I actually do 2 pi minus theta. So just a quick example in the third quadrant, if I had something like 7 pi over 6, which is in that third quadrant, I would do theta, which is 7 pi over 6, minus pi, 6 pi over 6, which is pi over 6. If I had something in the fourth quadrant, so again, bigger than 1.5 but less than 2, something like 11 pi over 6, I would do 2 pi minus that. 2 pi is 12 pi over 6, and I end up with pi over 6. So notice again all those special angles. As you move around your unit circle, the reference angle is actually equal to pi over that angle. If it's not one of those special angles, then we would do pi minus theta in the second quadrant, theta minus pi in the third quadrant, and 2 pi minus theta in the fourth quadrant. All right, so example 7 says find the reference angle theta prime and sketch theta and theta prime in standard position. So we just said this was one of our special angles, so theta prime would be pi over 3. If I were to draw each of these on my unit circle, theta would be from my initial position to 2 pi over 3, which would be here, and the reference angle would be here. 9 pi over 2, my reference angle is pi over 2. It's one of those special angles. 9 pi over 2 would be 4 1/2 pi. Remember, 4 takes us all the way back around to the even side, and I'd go past it 1/2. So I go all the way around and back, and that's theta. Theta prime is just the single curve. So keep in mind all reference angles are going to be 90 degrees or less, which means they'll always be in quadrant 1. All right, example 8, find the sine, cosine, and tangent of the angle without a calculator. So we go back to kind of what we learned in the first, in the 4.2 when we talked about unit circle. 5 pi over 4. Let's try to do it without looking at our unit circle. So a pi over 4, the coordinate point there is root 2 over 2 and root 2 over 2. And the tangent is 1. 5 over 4 is 1 and 1/4, which is actually just past the x-axis into the third quadrant. And in that quadrant, all students take calculus. Tangent is positive. The other two are negative. So the sine is a negative root 2 over 2. The cosine is a negative root 2 over 2. And the tangent is a positive 1. Example 9 says use a calculator to evaluate the trig function and round your answer to 4 decimal places. So by now we've done these a lot. It's just important to make sure you're paying attention to your mode. This is cotangent of 4.3 and it doesn't have a degree on it, which means that this has to be in radians. So I would do 1 over the tangent of 4.3, again making sure my calculator is in radians. And I get 0.4375 when I round it to 4 decimal places. Secant of 213 degrees, now I'm back in degrees. And this would be 1 over cosine 213. Negative 1.19236, so 24. All right, example 10 says find 2 solutions of each equation and give your answers in degrees and radians. Don't use a calculator. So I'm actually going to pull the unit circle in so we can visualize this. So this is saying, tell me, so this first one says sine of theta equals 1/2. So I'm basically asking for what's theta, which means my answer should be in an angle, and in the instructions it says in degrees and both radians, in which my sine is 1/2. So I'm looking for where on my unit circle my y equals 1/2. As you move around your unit circle, you'll notice the y is 1/2 here, positive 1/2, and it's also positive 1/2 here, which means there's 2 answers here, pi over 6, 5 pi over 6, and that's in the radians, and then also in degrees, 30 degrees and 150 degrees. So what this really leads us to is where at the end of the chapter we do inverse trig functions where you're given the answer and the trig function and you're looking for the angle. So we're kind of just getting our feet wet with this. Now look at B. B says the sine of theta is negative 1/2. So as I move around my unit circle, I'm looking for where y is negative 1/2, which happens here and here, again 2 places. My answer would be 7 pi over 6, which is also 210 degrees. And 11 pi over 6, which is also 330 degrees. Okay, last up, and we've done this before. Again, we're just kind of going back through them. This says the displacement from equilibrium of an oscillating weight suspended by a spring is given by y of t equals 2 sine 6t, where y is the displacement in centimeters and t is the time in seconds. Find the displacement when A, t is 0, B, t is 1/4, and C, t is 1/2. So displacement from equilibrium means if you could picture like a spring and you were to pull that motion down. As you pull it down, that spring goes down and up and down and up and down and up. And it creates a pattern that looks almost like a wave, which we're going to learn very soon in the next section actually, that could be a sine curve. So they already found the equation that makes that curve, which is y of t equals 2 sine 6t. You don't have to find that yet. And then it gives you the 3 different points it wants to know, which is when t is 0, when t is 1/4, and when t is 1/2. So all we have to do is take those t values and plug them in. 2 sine 6 times 0, 2 sine 6 times 1/4, and 2 sine 6 times 1/2. So this is 2 times the sine of 0, sine of 0, this is 1, 0, so the sine is 0. 2 times 0 is 0, which makes sense. If we haven't pulled that spring at all, there should be no displacement. B, 2 sine, this would be, of 3/2. Now there's no degree measurement in this, which means this is in radians, and I have to use my calculator. I'm going to make sure my mode is in radians, and then I'm going to just type 2 sine 3 divided by 2. And I get 1.994. Actually, 1.9949. So let's just say 1.995. If it said to round to the nearest tenth, because it doesn't tell you in this one, it would be 2.0 centimeters. So it's 2 centimeters off of my initial position. And the last one, 2 sine 6 times 1/2 would be sine of 3. Again, that's in radians. So I do 2 sine of 3, and I get 0.2822. If it asked me to round nearest tenth, it'd be 0.3 centimeters off of my initial place. All right, that wraps up 4-4. Make sure you do the homework and have a great weekend.